మేము ఇట్లా చేయబోతున్నాము. నేను వెయిటేజ్ అను
Hello everyone, good evening one and all. Welcome to ACE Engineering Academy. ISRO question paper analysis and discussion. Today it was held for electrical engineering. I hope all the students was done very well. Now we are going to discuss all the solutions with respect to all the subjects one by one. Now I would like to take that weightage analysis first. After that my colleagues will explain for each and every question with the solutions. Thank you. Hello guys, today electrical engineering question paper, once you see that the weightage of all the subjects, this question paper will power packed. I think under power system and electrical machines and power electronic circuits, these three subjects are dominating the entire question paper today, ISRO question paper. And the weightage analysis is, the first subject is electrical machines. 27 questions were given here, and power systems 25 questions, and power electronics 12 questions. See that how the core subjects are dominating this year ISRO examination. And next one is electrical measurements 3 questions, and electrical circuits 4 questions, control systems 4 questions, and electromagnetic field 2 questions, engineering mathematics 3 questions, and finally aptitude is 15 questions, totally 95 questions. Once you see the entire total question paper is filled with that core subjects like electrical machines, power systems and power electronics. And I will say that the today's question paper is, it is above average or average question paper, I can say that. Now my colleagues are going to take each and every subject and they are going to provide the detailed solutions. Right, first subject I would like to consider that electrical circuit. Under electrical circuit 4 questions are there. Guys, these are very simple questions. The first question is the value of the current in the amperes, through the 1 farad capacitor. Guys, if you see that here, this one is the entire network. Usually if you want to get it that current, we need to take the entire current, but once you identify that by looking into the source terminals, this is going to the bridge. The bridge is balanced condition or not. Even though it is AC here, this 1 ohm and 0.5 farad, 1 ohm and 0.5 farad, here 1 ohm, here 1 ohm. That's why the bridge is going to be balanced. The resultant current in the 1 ohm, 1 farad is equal to 0. Option A is the correct one. And the next one. See, the next question is a DC circuit shown in the figure has a voltage source V, a current I and several resistors. A particular resistor R dissipated a power of 4 watts when V alone is active. The same resistor R dissipates a power of 9 watts when I alone is active. The power dissipated by R when both sources are active will be. This will come under superposition theorem. He was provided the here powers, individual powers here. I think you are having a direct formula to obtain that the entire power with the individual powers. The total power by knowing the individual power P is equal to under root P1 plus or minus under root P2 whole square. And this is under root P1. P1 what is given? With respect to here voltage source here or current source given as a 4 and the next individual power is given 9 watts. By taking this one here 2 plus or minus 3 whole square, this we are going to get it the 1 watt as well as 25 watts here. Guys, if you see that the option, both our options are given. If you take plus, you are getting that here D, and if you take minus, you are getting 1 watt. We can take it A and D, but usually positive, if you consider that, you will get the option D is the correct one. Option D is the correct one. You will consider that after D is the correct one, if you take 1. Actually, answer the options A and D both are correct here. Now, let us take the next example. In a series circuit shown in the figure, for series resonance, the value of coupling coefficient will be here. RLC series circuit, you have to estimate the coupling coefficient. This is the R plus J times of XL minus XC. Instead of XL, XL equivalent. Now, at resonance, imaginary part is equal to 0, nothing but XL equivalent is equal to XC. Here, that value is given 12. Now, you have to take that the coupling, this is the series aiding. Under series aiding, you know that L equivalent is equal to L1 plus L2 plus 2M. Now, XL equivalent is equal to XL1 plus XL2 plus 2 times of M. That M you can express in terms of the coupling coefficient 2K times of under root XL1 into XL2. Here XL equivalent already we got under resonance condition, that is 12, and XL1 is given 2 plus 8 plus 2K times of under root 2 times of 2 into 8. Now, this here we are getting 2, since 12 minus 10 is 2 and 2K into 16 under root is 4. That's why K value you are getting finally 1 by 4, which is equal to 0.25. Coupling coefficient is 0.25, which is the correct option is A. Let us take the next question. This is the ladder network here. Once you see that the infinite network, under infinite network, you know that you need to replace that the infinite network as a finite network by identifying the repetition unit. Once you see that this is repeating infinite times, that's why the entire network across this part we are going to replace as a single one. That is what? Here I can take it that single resistance value is the equivalent resistance, which I can take it as Rx. Now, here it is also Rx. Then you will get finally the infinite network as a finite network. With that, we are able to define the positions of the resistors to estimate the equivalent resistance. Now, R equivalent is Rx I have taken. Now, this one 1 ohm is given. This is going to be Rx. Now, the equivalent resistance Rx, by knowing the positions of the resistors, so one is parallel with Rx and total in series with 1 plus 1. Now, finally, Rx is equal to 1 into Rx by 1 plus Rx plus 2. With this, once you cross multiply that, here Rx plus Rx square, and here 2 into Rx plus Rx is 3Rx plus 2 you are getting. Now, finally, we are getting that quadratic expression. Once you simplify this quadratic expression, we are getting that as a Rx square minus 2Rx minus 2 is equal to 0. Now, the Rx value you will get it as a minus B plus or minus under root B square minus 4AC. Minus into minus is plus 2. Here we are getting under root B square minus 4AC. B square is 4 square minus 4 minus 2. Nothing but minus into minus is plus. Nothing but 4 plus 8 is 12 by 2 times of A. A is equal to 1. Now you can take it common 2 here. 12 means you can write 4 into 3. Finally, you are getting that 1 plus or minus root 3. Now Rx value you are getting that 1 plus root 3, because if you take that negative, resistance value will get negative, but as per the given network, resistance value is positive. With that I can take it, the correct option is D is the correct one. These are the questions given under network theory. I hope you attempt all with the correct options. Thank you.
లేదు less than 5 minutes. Yeah, dear students, now there are 4 questions from the control system. Now observe first question. Clearly given characteristic question third order. Very simple question here. Third order, you can use Routh-Hurwitz method or simple shortcut here. Internal product observe 5 into 7 35. Internal product here, shortcut simple. Internal product is greater than external product here. So obviously system is stable system. Stable system. For stable system, all poles should be left side only. So right side poles are 0, left side poles are highest power. Left side poles here highest power 3 minus 0 equal to 3. So correct answer is 3 is right answer. So your options 3 is correct answer. This is a shortcut technique. Or if you want regular method, you can use the RH method. That is the first question. Now coming to the second question here. Here observe S term is missing. Nicely here observe S term is missing. S term is missing means no doubt poles are S square equal to minus 100 imaginary poles. So this is the undamped system. B goes to 1 here. B goes to 1 here. In the option observe B goes to 1 1. So option A and option B are wrong options. Simple. So check the verify one more option here. S square, first option A observe here. So omega n square equal to 4, omega n equal to 2 guys. Now 2 zeta omega n equal to 5 middle term. 2 zeta omega 5, omega n equal to 2 zeta product of omega n equal to 2 equal to 5. Zeta equal to 5 by 4 dear. 5 by 4 greater than 1. So it is a overdamped system. Overdamped system means A belongs to third. So obviously option D is right answer. Option D is right answer. This is the second question. Now coming to third question here. But here many people are going to commit the mistake. What is the logic here? Examiner was given closed loop trans function is given. So if you simply for DC gain substitute S equal to 0, simple technique here substitute S equal to 0. So 4 by 13, many people are going to select the 4 by 13, but question paper is logical asked, given is closed loop, is asking open loop here. So first our duty to convert open loop trans function from closed loop. Direct technique here, closed loop trans function by 1 minus closed loop trans function. This is a one technique. Or simple one more logic here, shortcut technique. This term subtract from here guys. Subtract from here. Whatever the numerator term subtract here. After subtraction what happens here? Open loop trans function here. This is a one technique. Another technique here, S plus 4 by subtract here. S square. S 7s minus S here plus 6s. Now 4, 13 minus 4 plus 9. Wherever S is there, substitute S equal to 0 for DC gain. Wherever S is there, substitute S equal to 0. S equal to 0. So obviously 4 by 9 is correct answer. So right answer is 4 by 9. But many people select 4 by 13. This is the correct answer. Option B is the right answer. This is the third question. Now coming to the last question. Here at very high frequency, the logic here at very high frequency, the formula P minus Z product of into minus 20. Minus 20. Number of poles observe here. Number of poles are 8 here. 8 minus zeros are 5. Product of minus 20. So 3 into minus 20 equal to minus 60 dB per decade. So given option is minus 60 dB per decade. Obviously option A is correct answer. These are the question from the control system.
Right. I am going to discuss the solutions from the measurement subject. The question here is, this is electrodynamometer instrument, that is wattmeter question. They are asking like, right, 50 volts range electrodynamometer voltmeter is given. Current range is given 0.05. Full scale deflection current 90 degrees. Control spring constant is given. And after that, initial inductance is given. Finally, they are asking like total change in the mutual inductance. So what is the formula here? Theta is equal to I square by Kc into dm by d theta. Here what is I value? 90 degrees into what is Kc has given? 0.5 into 10 power minus 6 Newton meter per degree. Here 90 is degrees and here also degrees. So degree cancel, no need to change it. Divided by I square. What is I square here? 0.05 into 0.05. This value you are getting as dm by d theta. But generally the people do the mistake is, after degree cancel, whatever the value you are getting, that is dm by d theta, whatever the value you are getting, that will be Henry per radian, because dl by d theta or dm by d theta always must be with respect to radian as a corresponding degree. So therefore, after getting this, he is asking dm value. What is that? dm by d theta into d theta. Here this is having the denominator unit of radian, therefore this angle must be 90 degrees must be converted into radian. If you simplify this, you are going to get the answer as 28.3 millihenry as the answer. If you are not taking that into radian, answer will be separate, that's why. So you have to take the corresponding angle in terms of radian. Answer is 28.3 Henry. And next one is, it is a bridge question, very lengthy question. In this, he is asking like current through the galvanometer. It is lengthy numerical. In this, first you have to calculate RTH value. Nothing but he has given unbalanced bridge and current through the galvanometer he is asking. So in order to find out that, in this entire circuit, RTH you have to calculate and then VTH also you have to calculate. Just by using the Thevenin's theorem model, RTH and VTH, after calculating this, VTH, right, in series with, this is VTH, this is RTH, and here correspondingly load element means 300 ohm, we can write like this. This current he is asking. Just after calculating RTH by taking the, what is that, voltage source short circuited, and we need to find out the resistance between these two. And then next one, VTH calculation by taking the as it is circuit voltage between these two. After finding these two, if you substitute the values here, you are going to get I value approximately 43 microampere something. So nearest value will be 42.80. According to the given values, among the options, this is the nearest value. Right, the next question is, this is energy meter question. Very popular topic in the energy meter is phantom loading. In this phantom loading, what is the power loss formula? Power loss is equal to power loss in the potential coil plus power loss in the current coil. What is the potential coil power loss? V square by RPC plus power loss in the current coil is V into I. Now what is V phase? What is the value? 230. 230 square by RPC value, he has given that 5000 plus what is the voltage given to the current coil? That is 6 volts. 6 into current is given as 5. If you simplify this, you are going to get approximately 40.5 watts. So this is the answer. So 40.5 watts. So these are the questions from the measurement subject. Right. Now I am going to give the key of power system subject. As a faculty is not available, I am giving only key now. Detailed solutions will be uploaded later. The question here is, for this 11th question, right, answer here is option D. Next one, the 50 MVA 3-phase 33 question, the 14th question is option A. And 17th question, hydroelectric generating station, option C. 21st, large size steam power plants and nuclear power plants are suitable for generally nuclear as well as correspondingly steam power stations. We can say better option, base loads. Superheated steam always, option C here. 23rd question, 96 megavolt ampere reactive. 26th one, option A. And 27th question, effect of temperature rise in overhead, right, lines 2 is to increase the sag. If the sag is increased, simply temperature we can relate it. That's why answer is A. Which type of insulators are used on 132 kV? Generally we go for disc type. Increase in the frequency of transmission line will increase the line resistance. The 33 question is option B. 43 question is directly formula, option A. 44 question, option D. 51 question, option A. 57th question, option D. Just verify your key. 58th question, option D. 62. Current chopping mainly occurs in, these are direct question, air blast circuit breakers, option A. And 66th question, 6.25 amperes, first option, option A. 67th question, option C, 0.2 mm. 68th question, 16.33 kV, option C. The arc voltage in a circuit breaker is, right? The directional overcurrent relay is used for ring main distribution line. And 75th question, option B. 76th one, A and D are equal. So this is simply we can say linear passive elements. So therefore automatically A and D are equal. 77th one, option B. So these are the questions from the power system and this is the key. There is one more question in this. The arc voltage in a circuit breaker is always in phase with the arc current. So this is the key. So these are the questions from the power systems.
Now let us discuss the mathematics questions given in ISRO examination. From mathematics subject, 3 questions were given. Now one question is from the differential equation topic, one question is from the matrix theory, next one question is from the Laplace transform. Now let us discuss the solutions of each. Now start with this question. If a particle moves along a straight line with velocity given by dy by dt equal to 1 plus y. A particle is moving along the straight line with velocity given by this. In this velocity, y denotes the distance travelled and t denotes the time taken to travel the distance. Then we are asked to find the time taken by the particle to travel the distance of 999 meters, 999 meters. The velocity is given means indirectly we are given the differential equation. From the differential equation we try to find a solution by one of the method because it is a first order, first degree differential equation. After find the solution, from the solution if distance is required we can find the distance, if the time is required we can find the time. But here distance is already given. To cover that distance we require the time. So we can find the time here and that is given already in the options. So let us do the problem. The velocity is given by dy by dt equal to 1 plus y. It is a first order, first degree differential equation. To find a solution of we have many methods, but out of all the very first one simple method is the variable separable method. By applying the variable separable method we can write the all y's and dy on one side, all t's and dt on other side. That is function of y dy on one side, function of t dt on other side, and then we take the integration. Here bring this side 1 by 1 plus y dy equal to dt, and then taking the integration on both sides plus integral constant c. This is just like integral of 1 by x dx form. So integral of 1 by 1 plus y dy is log of 1 plus y equal to other side integral of 1 dt is t plus c. Now this is the general solution of the differential equation. From this, if you want to write the time t, we can write the time t, or if you want to write the distance, we can write the distance by writing the y. If you want to write the y, shift the log other side and we express the y in terms of t. But in this problem we are asked to find the time taken by the particle to travel a distance of 999 meters. So already distance is given, so we write the y value, the 999, so that we get the time t directly. Now to find the particular time t, we never consider the arbitrary constant c. Therefore t equal to log of 1 plus to travel this distance 999 meters. This is equal to log of 1000. This is the answer. So this much time is required to travel the 999 meters. This is the time. So this answer is given in the option C. It is a correct answer. So this is about the first problem. Now we go to the second problem. It is a question from the matrix theory. If lambda cube lambda square minus 21 lambda plus minus 45 equal to 0 is the characteristic equation of a coefficient matrix in the homogeneous system. A is the coefficient matrix of the homogeneous system. For this coefficient matrix already characteristic equation is given. Then adjoint of A. We are asked to find the adjoint of adjoint matrix of this coefficient matrix. Already we know the directive formula for this adjoint of general order nth order matrix. From that we try to write for this particular order. Here the order is, from this we can set order of the matrix is 3 by 3 only, and for this 3 by 3 characteristic equation is given. Now let us write the general result for this adjoint of adjoint matrix. adjoint of A n cross n equal to determinant of A power n minus 2 into A. It is a result for general order nth order matrix to write the adjoint of adjoint matrix for any square matrix. But we require this for particular order 3 by 3. So replace n with a 3. Adjoint of A 3 by 3 matrix equal to determinant of A power n minus 2, that is 3 minus 2 into A. This is equal to determinant of A into A. So this is the scalar multiple of matrix A. That scalar is the determinant of the matrix. If you know the determinant of A, we can write here, that will give the our required matrix. Now we try to write the determinant of the matrix. But in this problem, determinant of the matrix is not given directly, but indirectly given from the characteristic equation. The general form of the characteristic equation of any 3 by 3 matrix is lambda cube minus trace of A into lambda square plus the quotient, some quotient into lambda minus. First to start with the positive sign, alternator at the minus, plus, minus. Then determinant of A equal to 0. Okay. This is a characteristic equation from any given 3 by 3 matrix. If you compare with this, lambda cube minus lambda square, but here minus trace into lambda square plus some quotient into lambda plus determinant. Okay, this is a general form of this. Now from this characteristic equation, we can write the determinant of the matrix. It is a characteristic equation of any some 3 by 3 matrix. Here the determinant is minus 45 into A. Therefore, adjoint of A 3 by 3 matrix equal to minus 45A. That is, C is the correct answer. Now it is the characteristic equation. From the characteristic equation, we can write the determinant. But here I wrote the characteristic equation of some 3 by 3 matrix, general characteristic equation. So just like this, determinant is given here. From this, we can write this. So option C is correct. Now let us go to the next problem. It is a question from the Laplace transform. We require the Laplace transform of cos of AT minus B. First we simplify this. Cos of AT minus B. This is equal to, by using the cos A plus B and cos A minus B, we can have the expansion of this. But here we require the cos of A minus B expansion. Cos of AT into cos of B. If it is minus, here we get the plus, plus sine of AT into sine of B. Cos A minus B, cos of A minus B, cos A cos B plus sine A sine B. And take the Laplace transform on both sides. Cos of AT minus B equal to Laplace transform this function. It is constant, it is a function of t. We apply the Laplace only for function of t. Cos B is a constant into Laplace transform of cos AT plus sin B is a constant, Laplace transform of sin AT. This is equal to cos B is the constant into Laplace transform cos AT is S by s square plus a square plus sin b is a constant into Laplace transform sin 8 is a by s square plus a square, and after simplification this will be now we can get the here 1 by s square plus a square, 1 by s square plus a square is common, s into cos of b plus a into sin of b divided by s square plus a square. So this is given in option A, s into cos b plus a into sin b by s square plus a square. This is given in option A. So A is the correct answer. So these are the questions from the mathematics part.
Hello friends, now let's have a look at the solutions for aptitude part. The number of questions given were 15, out of which 5 are for 2 marks each and 10 questions were 1 mark each. Now going ahead with coming to the level of difficulty of the paper over here, the questions given in aptitude are easy to moderate, I can say, not more than moderate level. So all were almost easy only. Now let's have a look at the first question over there, question number 81. So 81 to 95 all are from aptitude only. Which of the boxes comes next in the sequence, they are saying. Now going ahead with here, we are having this pattern that is being changing over here. So if you observe this one, so this you look at alternately. So this is having the square box over there, shifting by 2 places and coming over here, shifting by how many places after that? So for you to come to this place, it is shifting by how many places? 1, 2, 3. 3 places it is shifting. That means they are shifting by 2 places and 3 places. So here also what is happening here? So this is shifting by how many places? 1, 2. So to come here. Again this is also shifting by 2 places in clockwise direction. In the next alternate diagram, so this should shift by 3 places, means 1, 2, 3. So the dark one has to come at this corner. This also should shift by 3 places. 1, 2, 3, that should come here. So dot should come here and the dark square must come over here. That is there in option B, hence it should be option B. Next, question number 82. This is from Venn diagrams topic. The number of students who took history and geography among other subject was. So who is taking history as well as geography among the other subject? Okay.
So this is history, this is geography given. Look at this common area belonging to history as well as geography. So they should take history as well as geography. They may be taking other subject also. So that if you count that area that I have highlighted, that is adding up to how much? So this is adding up to 13 plus 20, 25, 25 plus 20, 45, 45 plus 18 is adding up to 63. That should be option C. Next, problem number 83. So in this one, the series is repeating after every 4 patterns over there. So you will be having the same pattern, right? That will be option B, right? Next, going ahead with 84. Select a suitable figure that would replace the question mark. So if you observe this pair over here, this is square box, this is 3 circles over here. They are interchanging the position. So circle is going there, square is coming over here. So there are 3 square boxes coming over here. So square and circle are interchanging their places. So here also triangle and line should interchange their places. You should get 3 triangles at the bottom, whereas line should go to the top. So if you observe the options there, so this can't be your answer. So here you are having 3 lines over there, not possible. 2 lines over there, 2 lines, L shapes over there, that is also not possible. The only possible answer is what? Option A. I repeat, these 2 symbols should interchange their positions. That should become 3, that symbol should become 3 symbols over here, this should become 1. So circle was 3 circles here, that became 1 circle, the single square became 3 squares over here. Similarly, this line, this L shape should become 1 and the triangle shape should become 3. So that is there only in this and this, but here the positions have not interchanged over here in option B. That's why it should be option A is correct. Option C and D you can straight away eliminate. Right dear? Next, question number 85. In the semester examination, most of the students in the first year of the engineering university failed in mathematics. The university authority discontinued the teacher's contract to teach the first year student mathematics. So here the point that you need to understand is between these two, which one is cost and which one is effect is what we need to find over here. So generally there, like you may be thinking like many students have failed because of which he was removed, or the faculty was removed, that's why they have failed. So there are 2 ways of thinking over here. So one thing that you can eliminate is both events A and B are independent, you can eliminate. Event A and B are effects of the independent causes also you can eliminate. So that is not so. Your confusion comes down to A and B, which is cause, which is effect. So generally, if you feel that like they have removed the faculty, so they were failed, there should be a reason for removing the faculty. So faculty will not be removed just like that. So the better way of looking at it would be, say suppose a teacher is being appointed, and in spite of he teaching, if the students are still failing, so that will definitely lead to what? Cancelling of the contract to the faculty. So this can become the effect and this can become the cause. That makes more sense over here. Hence your answer has to be A is the event, A is the cause and B will be the effect of that one. Hence I can say that the correct answer should be what? Option A. Next, a train traveling at 60 kilometers per hour enters a tunnel that is 5 kilometers long. The train is 1 kilometer long. How many minutes does it take for the whole train to pass through the tunnel? For the train to pass through the tunnel, the total distance the train has to travel is equal to length of the train plus length of the tunnel put together. So we know that the length of the train is 1 kilometer and the length of the tunnel is 5 kilometers. For the train to cross the tunnel, the total distance to be traveled is 6 kilometers over here. And we are aware that the train is capable of covering 60 kilometers per hour, means in 1 hour the train is capable of covering 60 kilometer distance. In 1 hour if it can cover 60 kilometer distance, from this I can say that in 1 minute train is capable of covering 6 kilometers, or I can simply say in 60 minutes the train can cover 60 kilometers. Let's start from there. So 1 hour 60 kilometers means 1 hour means 60 minutes. In 60 minutes the train is capable of covering 60 kilometers, I can say. In 60 minutes if the train can cover 60 kilometers, in 1 minute it can cover how much? So in 1 minute the train is capable of covering 1 kilometer. In 1 minute, the train is capable of covering 1 kilometer. For the train to cross the tunnel, the total distance to be travelled by the train is 6 kilometers only. To cover that 6 kilometers, train will take how much time over here? Straight away 1 minute it will take. Hence I can say that the correct answer is what? Option C. That should be C, right? So the question is, how many minutes does it take to cross this one? So in 1 minute if it can go 1 kilometer, in 6 minutes it can go how many kilometers? 6 kilometers, no? So in 1 minute it can go 1 kilometer, in 6 minutes it can go 6 kilometers. Hence the correct answer should be what? Option C. Next, 87. At what time between 5:30 and 6 will the hands of a clock be at right angles? So the angle between the hands of a clock would be right angles at, there is a direct formula for this, that is 30h plus or minus theta into 2 by 11 minutes past h o'clock. Minutes past h o'clock. So the angle between the minute hand and hour hand would be theta at 30h plus or minus theta into 2 by 11 minutes past h o'clock. Here h represents the time between 5 and 6, no, 5 to 6. So 5 is h over here, like 6 will represent h1. So in this one, two incidents will take place. One is before coincidence, one is after coincidence. 30h minus theta into 2 by 11 will represent before coincidence, means before the minute hand meeting the hour hand. So between 5:30 and 6 means that has to be after minute hand crossing the hour hand only. Hence I have to consider only the second case over here. So I have to consider only 30h plus theta into 2 by 11 minutes past 5 o'clock. That will become, I repeat, 30h minus theta into 2 by 11 here will represent before the minute hand meeting the hour hand. This is before coincidence. 30h plus theta into 2 by 11 will be the case where the minute hand might have crossed the hour hand. So here as they are saying the time is between 5:30 and 6, by that time the minute hand might have crossed the hour hand. So I have to consider only the second case over here. Substitute h equal to 5 here, so that gives you 30 into 5 plus theta, angle given as right angles means theta should be 90 degrees into 2 by 11 is what I am looking for. So I am looking for this case. So this is coming out to be 190, like 150 plus 90, 240, 240 into 2 is 480. So overall it is 480 by 11, that gives you 1143 is 473, remainder is 7. 43 7 by 11 minutes past 5 o'clock. That means that will happen at 5:43 7 by 11 minutes. Hence it has to be 43 7 by 11 minutes past 5 o'clock. Next dear, problem number 88. A 4-person crew from Classic Colors is painting Mr. Field's house. Michael is painting the front of the house. Michael is painting the front of the house. Michael is painting the front of the house. Second person, Ross is in the alley behind the house painting the back. So Ross is painting in the back of the house. Jade is painting the window frames. Jade is painting the window frames. Next, if Michael switches, like they have also given frames on the north side and Sean is print on the south. So Sean is painting on the south. So this window frames is on the north side, that also they have given. Now what is the condition they have mentioned? The condition is, if Michael switches places with Jade and Jade then switches places with Sean. So Michael is switching the place with Jade. So Michael is switching place with Jade. So Michael goes here, Jade comes here. Then now Jade is here, Michael is here. And Jade then switches the place with Sean. Where is Sean? If Jade is now switching the place with Sean, now Sean will come here, Jade will go there. So finally where is Sean located? Sean will come here, that will be the front of the house. Hence your answer has to be option C. Next, problem number 89. There are 15 people in a conference and all of them shake hands with each other only once at the end of the conference. How many handshakes will be there altogether? This is a problem related to permutations and combinations. So here for a shake hand to take place, there should be two people. Between any two people, see, if every person is giving shake hand to every other person, between a combination of every two people, there will be one shake hand count. So if there are n people in a group, to count the number of shake hands, it will be NC2. A combination of two people out of n people is what you have to look for. That NC2 is nothing but n into n minus 1 by 2. So n into n minus 1 by 2 I can say. To count the number of shake hands in a meeting where n persons are shaking hands one with each other, it will be n into n minus 1 by 2, that is equal to how much? So here n is given as how much? How many people are there? 15 people are there. So that will be 15 into 14 by 2. On simplification, that will give you how much? 105. Hence I can say that the total number of handshakes in the meeting would be 105. It should be option B here. Option B. Next, problem number 90. This is something related to data interpretation. It is a simple observation problem, I can say. Study the following table carefully and answer the questions given below. Number of 5 types of cars produced and rejected for defects by company over the years is mentioned. Now the question is, please be careful, it is given for 2 marks, then the values given over here are in thousands. So units you have to be very careful with. Now here they have given produced is 20, it is not just 20 number, it is 20 thousands. The question is what? They are asking you for what was the difference in the number of C-type cars produced between 1984 and 1985. 1984 and 1985, between 1984 and 1985, C-type cars production difference they are asking you for. During 1984, C-type cars produced are 20,000. During 1985, the C-type cars produced are 17,000. They are asking you for the difference between the 20,000 and 17,000. That has to be how much? 3,000. So difference they are asking you for. So 1984 it is 20,000. 1985 it is 17,000. The difference is how much? 3,000. Hence your answer has to be option C. Next, problem number 91. This is something related to syllogism topic. Now, what is given over there? So here it is mentioned that all mangoes are golden in color. 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 No golden color things are cheap. No golden color things are cheap. So golden color things and cheap cannot have any intersection between them. Now, all mangoes are cheap. All mangoes are cheap is wrong. So directly I can say that is wrong from the diagram. In the basic diagram itself it is not working. Golden colored mangoes are not cheap. Golden colored mangoes are not cheap. That is definitely true because all the mangoes are golden in color. Golden and cheap cannot have any intersection means no mango can touch cheap. So that's why golden colored mangoes are not cheap is definitely correct. So that's why second one is definitely true. Hence I can say that only conclusion 2 follows. Next, problem number 92. This is a very simple one, which is find the inserting the missing character type. Which one will replace the question mark they are saying. Now observe some pattern over here in the numbers. This is 2, 4, 6. 2 plus 4 is 6. Only numbers you look at. 5, 9. 5 plus 9 is 14. Here 3, 5. 3 plus 5 should be what? 8. In the option you are going to get, you should have 8 at the bottom. Look at the option which is having 8 at the bottom. There is only one option which is having 8 at the bottom. Hence that should be option D. Straight away you can say that. No sir, I want the logic for the letters also. If you are willing to look at the letters over here, there is a difference of 2. This is letter 1, this is letter 3. Here there is a difference of 2. Here there is a difference of 2. Here also there should be a difference of 2. So that's why after I with a difference of 2, which letter will come? K will come. That's why K8. So here also same logic is there. This is 13th letter M. This is 15th letter. This is 17th letter. There is a difference of 2 maintained. Right here. So without you even looking at that letter, still you can answer this problem. Next, problem number 93. This is based on shifting of the characters over there. You observe one pattern over here. see, like whenever you are having two colored parts over there, in between them whatever symbol is there, diagonally opposite to that same symbol will be there. That is the first observation. If that is the case, you can here also star is there, star. Here you have heart symbol, here also you have heart. Here you are having plus, here also you are having plus. Here you are having star, again you are having star over there. So again, if you are going ahead with, in the options you are going to get where whatever is the symbol that is appearing in the middle should have the same symbol on the opposite of it. Now if you observe, heart is there over here, there is a chance, right? Next, so here star is there, here also star is there, there is a chance. Here star is there, there is a chance. Here heart is there, there is a chance. So I cannot decide what is my answer with that observation alone. Let's move ahead further. Every time this place is shifting by how many places, you just check. So this is shifting by one place, that is also shifting by one place, so like in clockwise direction. So here you are having dark color over here. In the next step what will happen, this will come here and this will go there. So in the like answer figure you are going to get, you should have the dark colors here and here. So look at that. So you can eliminate this option here straight away. So your answer is can't be this one. Your answer is lying between this and this. Between this and this it is there. Let's go back again. So to decide what is your answer, you are already having star opposite star over here. In the next one definitely star and star will not be opposite. That's why you can eliminate which option? This one you can eliminate. So what is your answer? Option D. That is a simple observation problem, dear. There is nothing to explain much over there. Last two questions. If all the statements are true, which of the following gives the correct order of the seating arrangements? There are 6 seats, each with a different color, red, orange, yellow, green, blue and purple. Seat 1 is not orange, blue or purple. Seat 1 is not orange, blue or purple. Seat 1 is not orange, blue or purple. So nowhere you are having seat 1 as orange, green or purple, orange, blue or purple. So no option you can eliminate. The red seat is either seat 4 or 6. So red seat should be either 4th one or 6th one. So red seat is in 6th place, there is a possibility. Red seat is in 4th place, there is a possibility. Here red is in 4th, there is a possibility. Here red is in 6th, there is a possibility. Still I am unable to eliminate. Next, third condition. The green seat is between yellow and blue. The green is between yellow and blue. Go ahead. Green is between yellow and blue. So here green is between yellow and blue. I can eliminate option A. Green is between yellow and blue. There is a chance. Green is between yellow and purple. So I can eliminate this also. Here green is not between yellow and blue. So this also I can eliminate. So what am I left with? I am left with only option B. Without you even reading the next two conditions like condition 4, condition 5, still you can answer the question over there. So in the exam, don't try to arrange everything and don't choose the answer. After every condition, you keep on checking the process of eliminating the options. In that case, after reading the third condition itself, we are able to decide what is the answer for that problem. Next, last one. This is also from the part of syllogism. Right. Some books are pens, some books are pens, some books are pens, some books are pens, and no pen is pencil, no pen is pencil, no pen is pencil. Pen and pencil cannot have any intersection between them. Some pens are books, definitely true, that is happening in the basic diagram. So if the positive conclusion is valid in the basic diagram, testing for alternate diagram not needed. Next, some pencils are books. Some pencils are books is not happening over here. I can eliminate that. Not working in the basic diagram, testing for alternate diagram not needed. Some books are not pencils. This you have to verify. Some books are not pencils. Here books and pencils are not having intersection, that is valid in the basic diagram. But will that be valid in the alternate diagram also? Definitely yes, because definitely some books will always be there inside the pens. Those books which are inside the pens can never touch pencils. That means this will definitely be true even in any of the alternate diagram you are going to draw. Hence that will definitely be valid. Next, last one. All, this is pencils, na? Okay. All pencils are books. All pencils are books is not valid. So this is also not correct. Hence your answer is what? Only 1 and 3 are valid. Hence it has to be option B. Right. So these are the key for the questions from 81 to 95 from aptitude part. Next my colleague will take over for the next subject. Thank you.
Hello my dear, let us discuss now questions from subject power electronics. Yeah, first question. A series capacitor committed inverter can operate satisfactorily if. So here the series capacitor inverter they are saying, means here we need to think about the load commutation. Generally the voltage source inverters we are having, and voltage source inverters we are using for inductive load, okay. But if I use the capacitor in series with that, that will become RLC. And in RLC we know for underdamped and overdamped case, if it is a underdamped, then we can achieve the load commutation. So here for underdamped means my zeta should be less than 1. Zeta equal to R by 2 under root C by L. That should be less than 1, right? So now I can square both sides. So I can write it as R square by 4 into C by L. That should be less than 1. But if you check the given options, they have given in terms of 1 by LC. Alright. So here I am going to multiply both sides. I am going to divide both sides with the LC. So I can write it as R square by 4 into C by L less than 1 by LC, and here I can write it as a upon LC, right. So if I check here, this CC will get cancelled out, right, and this L and this L, that will become L square. So it is a R square upon 4L square, that should be less than 1 by LC, right. So R square upon or 1 by LC is greater than R square upon 4LC. So option A is the correct option. Fine. Next, a single phase inverter has a square wave output voltage. What is the percentage of the fifth harmonic component in relation to the fundamental component? We know in single phase inverter V0 N RMS is equal to 1 by N into V0 1 RMS. Now here they are asking for fifth harmonic. Fifth harmonic means here my N equal to 5. Alright. So if I take N equal to 5, I can write it as V0 5 RMS is equal to 1 by 5 into V0 1 RMS. So from this I can write the ratio will be 0.2. V0 5 RMS upon V0 1 RMS. This ratio equal to 0.2. So in percentage I can write it as a 20%. Alright. So the correct answer is option C. Next. Yeah. In the given circuit, capacitor C is charged to 50 volt with upper plate positive, lower plate negative. Initial voltage across capacitor given, that is a 50 volt. Switch is closed at t equal to 0. Current through the circuit at t equal to 0 and voltage across capacitor are respectively. So here final voltage across capacitor they are saying, means they are talking about the steady state voltage across the capacitor. If you check in this circuit, at t equal to 0, when I close the switch, then my capacitor will act as a voltage source of how much voltage? 50 volt voltage. Then can I say that across the resistor, at one side I am getting a voltage is 250, second side I am getting the voltage is 50 volt. So what is the voltage across resistor? It is a 250 minus 50 is equal to, according to Ohm's law, it is equal to I into R, that is 20. Resistor value is 20. So from this I can say I equal to 200 upon 20, that is equal to 10 ampere. 10 ampere is the current flowing to the capacitor at t equal to 0, right. And what is the steady state voltage of the capacitor? If you check, if the switch is closed at t equal to 0, as time increases, my capacitor will go on charging. Up to which voltage it will be charged? Capacitor will be charged to the voltage of 250 volt supply voltage, right. So my steady state voltage or a final voltage across capacitor is 250 and current is a 10 ampere. So option D is the correct option. Alright, option D is the correct. Next, the capacitance of a reverse biased junction of a thyristor is 20 picofarad. So here junction capacitor given 20 picofarad. The charging current of this thyristor is 4 milliampere, the limiting value of dV by dt. So here can I write I is equal to C into dV by dt. You can write C or you can write CJ, junction capacitor, right. So here I can write current flowing is 4 milliampere, 4 into 10 to the power minus 3 is equal to C 20 picofarad, 20 into 10 to the power minus 12 into dV by dt. Alright. So by using this we can find dV by dt. So if you check, it is 4 into 10 to the power minus 3 upon 20 into 10 to the power minus 12 is equal to dV by dt. Alright, you can simplify this, you will get it as equal to 200 volt per microsecond. This is your dV by dt, right? 200 volt per microsecond. Option C is the correct option. Next, match the type of commutation in list 1 with their alternate name in list 2, right? So here we have class A, B, C, D commutation and they have given their alternate names. If you check, my class D commutation is nothing but voltage commutation, right? Class B commutation is nothing but your current commutation, right? Class D is a voltage commutation, means D is a 1, right? And class B, that is a B, option B here, class B is a current commutation. Current commutation means 6, right? So D1, B6. Apart from that, class C is known as a complementary commutation, right? Complementary commutation. So for C, I can say it as a 3, and remaining is class A is your 4th, that is equal to self commutation. So A4, B6, C3 and D1, these are only alternate names they have asked. Okay, so correct answer is option A. Option A is the correct option. Next, which of the following statement regarding freewheeling diode placed across a DC load is or are correct? So we know across a RL branch generally we are connecting a freewheeling diode in order to increase the output voltage of your rectifier. What happens without freewheeling diode? My output voltage will be having a small negative pulse. Alright, if I connect freewheeling diode, that negative pulse will be avoided. Okay, so here I can say that to prevent the reversal of load, actually it should be to prevent the reversal of load voltage, right? One word is missing here, but that should be the voltage. But anyways, we can take it as a correct. Next, to transfer the load current away from the source. Yes, if you check, if I connect a freewheeling diode, then when freewheeling diode conducts, my load current will be flowing only through the freewheeling diode. So source is not having any role in that, right? So second is also correct. And third, to transfer the load current away from the conducting thyristor. Yeah, when freewheeling diode conduct, then the thyristors will not be in a conduction mode. So third is also correct. So 1, 2, 3 all are correct. So option D is the correct option for this. Next, a single phase 2 pulse converter feeds RL load with sufficient smoothing so that the conduction is a continuous if the resistance of the load circuit is increased. So it is given that we are having a 2 pulse converter, means full wave rectifier and a RL load, right? And if the load resistance is increased, they are saying in RL load, if a load resistance increase, check in a RL load circuit operation, when inductor discharges, some part of inductor energy will be absorbed by your resistor also. So if you increase the value of resistor, there is a possibility that your inductor energy may become 0 before you apply the gate pulse to the next thyristor pair. Means there is a possibility of a discontinuous conduction. If you increase the resistance, load resistance, yeah, there is a possibility of discontinuous conduction. Option D is the correct option. All right. Yeah, if the latching current in the circuit shown below is 10 milliampere, obtain the minimum width of the gating pulse required to properly turn on the SCR. Yeah, these type of questions they are asked for gate examination, ESC also repeatedly, even in Janko Transco also, right? So it is purely inductive load given, DC voltage source given and thyristor here, right? If you check for this circuit, for t greater than 0, our current nature will be the ramp type nature, because DC voltage source across the inductor, your current nature will be the ramp type nature. And I need to maintain the gate signal till my SCR current reaches which value? Latching current. I need to maintain the gate signal till my SCR current reaches latching current value. So this is my IL. Here it is TP and this is a TP. Alright. Now how to find TP? Simply use here di by dt. When thyristor is in a conduction mode, can I say that voltage across inductor is equal to 120 and voltage across inductor is L into di by dt. is equal to 120. Now here put L into L value given 0.12 into di, change in the current is IL minus 0, that is IL, upon dt is Tp minus 0 upon Tp is equal to 120. Now from this I can write 0.12 IL is a 10 milliampere, 10 into 10 to the power minus 3 upon Tp is equal to 120, right? Simplify this, you will get the Tp. If you check, you will get it as a 10 microsecond. So Tp is a 10 microsecond. So correct answer is option C. Alright, option C is the correct option. Next, a single phase full converter feeding RLE load has the following data: source voltage given, frequency given, R load resistor and EMF. Firing angle is 30 degree. If the load inductance is large enough so that the output current is a ripple free, then the load power factor will be. Single phase full converter feeding to highly inductive load. What is the power factor? Thing here is they are asking about the load power factor, but the converter is a single phase full converter, means it is a rectifier circuit they are talking about. In rectifier circuit output is a DC. So DC side we don't have any power factor concept. So here there is some mistake in this question. It should be the input power factor. That should be the input power factor, right? And now we know in input power factor for single phase full converter feeding to highly inductive load, it is a 0.9 into cos alpha. Now it is a 0.9 into alpha cos alpha. Alpha is a 30 degree. So 0.9 into this is cos 30 root 3 by 2. If you check, you will get it as approximately 0.77. So option C is the correct option. Alright. And a chopper has Vs as the source voltage, R as the load resistance and alpha as the duty cycle. For the chopper, RMS value of the output voltage is, by default they are saying chopper. Chopper means you need to take here it as a step down chopper, right? In step down chopper, we know RMS value of the output voltage. What is V0 RMS? It is equal to under root to duty cycle. But here now the duty cycle is denoted with alpha. So it is under root alpha into input voltage Vs. So it is under root alpha into Vs. Option B is the correct option. Alright? Yeah. So friend, these are the questions from subject of power electronics they have asked. Right.
Yes, so good evening everyone. Hope everyone written well. So here in machines totally we have 27 questions from entire machines. Let's see one by one. So see the question here. 8-pole lap wound DC shunt generator is supplying 295 amperes to a load. The field current of generator given directly 5 amperes. Then what is the current per parallel path? So first of all, it is lap connected. So how many parallel paths will be there? 8. Number of parallel paths equal to number of poles only, no? 8 parallel paths are there. Okay. And given it is supplying, means load current is given 295, and field current given as 5 amperes. Then what is the armature current in a generator? Sum of the two, 300 amperes. This is the total armature current which is coming from 8 parallel paths. So the current is equally divided in 8 parallel paths. The current per parallel path is equal to 300 divided by 8 it is. So we will get 37.5 amperes it is. Okay, option A is the answer here for first question. Next question. You can observe a DC shunt motor takes 5 amps at 100 volts when running at light load. Light load means a little bit load is connected, some 10-20% like that. Shunt field resistance 50 ohms and armature resistance 0.2 ohm. What is the driving power of that motor? Means how much power is developed in that, how much power it is producing outside, delivering. That is gross mechanical power. What is the equation for P gross or mechanical power developed by motor is EB into IA, back EMF into armature current. So here we have to find back EMF first. It is taking 5 amps at 100 volts supply, and in that 50 ohm field resistance is there. This is the current taken, load current it is, line current. Then what is the armature current? We have field current equal to 100 divided by 50, 2 amps we get. Then armature current is, it is 5 minus 2, 3 amperes. And find out back EMF also, EB equals to V minus IARA. V is what, 100 minus IA is 3, RA is 0.2. So this is 99 point, check it is 0.6 no. So 99.4 volts it is, 0.6. Then EB it is, then substitute here, we get the gross mechanical power, which is the power driving here. EB is 99.4, armature current 3 amperes. Simplify this, around 300 but little less than 300, 298 watts it is. Option B is the correct. 298 point something we get, check it is. Okay. Next question. This is from series motor, has armature resistance of 1 ohm initially. Initially it is running at 800 RPM at 200 volts with a current of 15 amperes. Initially it is running current 15 and it is rotating at 800. What is the speed at which it will run when connected in series with the 10 ohm resistance? So much high resistance connected and taking same current here, current given same at same supply voltage. Then what will be the speed of the motor? So we have to find first back EMF initially. What is the back EMF at the first case? EB1 equal to supply voltage 200, initial current 15, 200 minus 15, armature resistance 1, so 185 volts it is. Now we added resistance of 10 ohms again, then this is 200 minus same current given 15, one more 10 added, total 11 ohms it is. Then we will get it is EB2 35 volts. Okay. Now substitute in the speed, N2 equal to, N1 is there 800 into N2 by N1 equal to EB2 by EB1. What is 5:1 by 5:2 ratio? Flux proportional to armature current. Current is same, it will be cancelled. So directly I am writing 35 divided by 185. Simplify this, we get speed 151 RPM it is. Okay. So option A is correct here. Next, this is directly, a transformer has full load copper loss of 400 watts. This is full load copper loss. Then what is the copper loss at half load condition? Half load. So at half load, what is the formula at half load? The copper loss at half full load is nothing but 1 by 2 whole square, means 1/4 of the full load copper loss, that is 400, nothing but 100 watts it is. So option D is correct. Next, this is also transferring of parameters. Easily we can do this. Given the secondary current in this figure, the secondary current means what is the current here? Okay. So first we will find primary current by transferring all parameters to primary side, and then secondary current we can find by turns ratio, no? That is available here. So anyway you can do, you can also transfer to secondary side, anything. Okay. First of all, what is the transformation ratio? K is 100. Now if you transfer this is inductance is there on primary, capacitance and reactance, means it will form a RLC circuit if you transfer to primary side. Then XC dash we get XC by K square. If you transfer to primary, dividing with K square, that value, then 20K by 20K XC by K square. K is 100, 100 square means 100 square, then it is 2 ohms we get. Similarly, this is resistance, let RL 40 K, RL dash if you transfer to primary, 40K by K square, 100 square, we get 4 ohms it is. Now these are the values with respect to primary side. Then primary side already inductance is there 5 ohms here. Then what is the primary current? I1 equal to voltage is there 10 volts divided by root of, this is RLC combination, R plus J XL minus XC. So directly I am writing 4 square plus XL minus XC is 5 minus 2, 3 square we get, root of R square plus total reactance square. So this is 16 plus 9, 25, which is 10 by 5, 2 amps it is. This is primary current, but we need secondary current in the question. So secondary current I2 by I1 can be written as N1 by N2 ratio. This is 1 by 100. Then what is I2 equals to? I1 is there, no? 2. 2 divided by 100 means 0.02 amperes. This is our secondary current, okay, which is option C here. Next, a 10 ohm resistive load is to be impedance matched by transformer to a source with 400 ohm of internal resistance. The ratio of primary to secondary turns of transformer should be dash. So here maybe this value is not correct, that's why slight difference we are getting. According to options it is not coming exactly. It should be 4000 here. If it is 4000, then we get 20 ohms. Impedance matching, nothing but load resistance is there, no? What is the load resistance given is 10 ohms, 10 ohm resistive load. With the source internal resistance is 400 ohms given. Now if you transfer that load resistance to source side or primary side, according to maximum power transfer theorem, the load resistance should be equal to magnitude of source resistance. Then what is RL is 10 ohms given, RL actually. Then what is RL dash? If you transfer the resistance to primary side, dividing with K square, no? Then 10 divided by K square equal to RS, which is 400 ohms it is. Now from this K square equals to 1 divided by 40. Then what is K? 1 by root 40, that is N2 by N1, but they are asking primary to secondary turns ratio, no? That's why K is N2 by N1, so I am taking directly N1 by N2. Then we get root 40 it is. If it is 400 here, means if it is 4000 initially source resistance, then here 400 we get, so root 400 is 20, but that is not coming, we are getting some other option here, some other value. So if it is 4000, then D is the correct one here. Next, which of the following connection of transformer will give the highest secondary line voltage? Generally, which transformer will give highest secondary voltages? We know that is delta star connection, delta star. So for unity turns ratio, primary secondary, we know that delta star will give root 3 times extra voltage than primary voltage. Okay, so delta star is the highest secondary terminal voltages among all connections. Remember this. So option C is here. Next, a 3-phase 50 Hz transformer has delta connected primary, star connected secondary, delta star transformer. The line voltage being 22K divided by 400 volts, line voltage given respectively. The secondary has a star connected balanced load of 0.8 lagging power factor. The line current on primary given means I1L given, how much? 5 amperes given, line current on primary side. The secondary phase current. So these type of questions little confused, we have to take care while answering. Phase, line, we have to everything check. Okay, line current given, but they are asking secondary phase current. So directly voltage current relation you have to apply. But see, how can we write? We need secondary phase current, I2 phase divided by I1 phase, phase current ratio equal to phase voltage ratio, transformation ratio, no? So I2 by I1 is equal to E1 phase by E2 phase. So what is the transformation ratio in terms of current? I1 by I2. But in terms of voltages, E2 phase by E1 phase. So I2 by I1 here I am writing directly E1 phase divided by E2 phase. Just apply here. We need secondary phase current, I2 phase equal to what is the primary phase current? Primary line given 5. As primary is delta connected, what is the phase current? By root 3. So I1 phase is 5 divided by root 3 into E1 phase, primary side line voltage given, and delta connection is there. So phase voltage also same, it is 22,000 divided by secondary phase voltage. Secondary line voltage there here 400. Then what is the phase voltage as it is star connected? By root 3. 400 by root 3 it is. Okay. So root 3 cancel. Now if you simplify, we get secondary phase current, it is around 275 amperes. Check the value, 275 by simplification. Option B is correct here. Next, if one of the main line connected to induction motor is changed, then what happened? Flux speed means RMF, rotating magnetic field. What is the speed of that and what is the direction of that? So this is nothing but simply phase sequence change. So one of the line is connected to induction motor changed. Then what happened? So flux speed remains same. RMF speed will not change, but only the direction is reversed. RMF direction will reverse. So option C correct for this. Next, if supply voltage to induction motor is increased 2 times, then torque is dash. Practically we should not increase the voltages, but according to question, we know torque is proportional to square of the supply voltage. Okay, then as voltage is 2 times, then what we get? 2V1 whole square, nothing but 4V1 square. So compared to initial value, now it is 4 times, okay, increased 4 times. Option C is correct. Next one, the rotor current in 3-phase induction motor is dash. So how it is related with respect to slip, they are asking, independent of slip or directly or inversely. So we know rotor current equation under running condition is SE2 divided by root of R2 square plus SX2 square. This is rotor current under running condition. But under running condition, we know slip is very low, then this is negligible term. Then approximately we can write it as SE2 divided by R2. This is 0 because slip is almost very small, 2%, 3% like that. So we can neglect this compared to R2 square value. Then we have only S here, SE2 by R2. So how the current is related? Current related directly proportional to slip it is. Directly proportional. Option B is correct. Next. Here a 3-phase 400 volt wound rotor induction motor has delta connected stator and a star connected rotor. Okay. Stator has 48 turns per phase. Stator having 48 turns per phase and rotor having 24 turns per phase. The standstill voltage across the slip ring. So little you have to take care. They are asking secondary voltage, but phase or line they didn't mention properly. That means across the slip ring means always it is line voltage across slip ring. But you may get E2 phase also, that may be wrong. So here line voltage we have to give the answer. First of all find phase voltage. Again E2 phase, secondary phase voltage or rotor phase voltage to stator phase voltage is equal to, in terms of turns ratio it is, that is E2 by E1 is N2 by N1 per phase, rotor to stator. Now what is E2 phase equal to? Secondary phase voltage first equals to primary phase voltage. Primary delta connection, phase voltage, line voltage same, 400 it is, into N2. N2 means rotor turns per phase 24 divided by 48. Then it is 1 by 2, here 200 we get. This is what? Phase voltage, secondary phase voltage it is, star connection. So line voltage equal to, so they are asking across the slip ring which is line voltage, means root 3 times of this. Root 3 times of 200 we get 346 volts it is. Okay, option D is correct for this. Next, here this is little we have to think, not directly we get, like the starting torque of 3-phase induction motor has maximum value. Starting torque is maximum starting torque. Okay, the rotor power factor is dash at that time. What is the rotor impedance? Generally Z2 equal to R2 plus JX2 and standstill condition. Okay, now what is the rotor power factor? Generally how we write power factor from impedance? R2 divided by root of R2 square plus X2 square, actually SX2 square. But here according to that maximum, motor has starting torque of induction motor is maximum value at the time of starting. Maximum starting means what is the slip at starting? 1. So 1 I am taking here. This is power factor, rotor power factor, it is cos phi 2. But we know in order to achieve maximum starting torque maximum at starting torque is maximum. Then according to maximum torque condition, what is the slip first? S equal to R2 by X2, no? Maximum torque condition it is, slip at maximum torque, S equal to R2 by X2. But at the time of starting, if you want maximum starting torque, then the S should be equal to 1. That means R2 equals to X2 here, R2 equals to X2. Now if you substitute here R2 divided by, in place of R2 you can take X2, that is X2 square plus X2 square, then how much we get? Or X2 equal to R2, let us take anything. So this is 2R2 square, no? 2R2 square, X2 equal to R2 I am taking, R2 divided by root of 2R2 square, then how much we get? 1 by root 2, this is 0.707, okay. So power factor is 0.707, option C is correct. Next, a 12 pole 3-phase alternator is coupled to an engine running at 500 rpm, means this alternator is driven with a turbine like this engine connected, which is rotating at 500 rpm and 12 poles are there in this. The alternator supplying an induction motor which has rated speed of 1500 rpm. The number of poles of that induction motor are dash. Okay. So who is supplying power to induction motor? To the induction motor, power is coming from alternator, and that alternator frequency important here for us. Okay. What is the frequency of that alternator? F equal to Np divided by 120, frequency of alternator. What is the speed? Our engine, it is rotating, alternator rotating at 500 into poles are 12 poles given, divided by 120. So if you simplify, we get it is 50 hertz only. So this is 50 hertz, frequency of motor getting frequency 50 hertz only, and poles not given, but given that motor rotating at 1500 rpm. So we know induction motor always rotates near to synchronous speeds only, near to synchronous speed. So frequency 50 hertz, and it is rotating almost near to 1500, means how many poles should be there? Poles. So N equal to 120 F divided by P. So poles are nothing but 4. If you approximately consider, it never rotated synchronous, near to that, but they given 1500 means approximately there, not rated speed. This is how the induction motor rotates at synchronous speed, never it is. So near to that we have to answer poles, we get 4 here, number of poles is 4, option A is correct. Next, in an induction motor, if air gap is increased, then what happens? If air gap increased, so whenever air gap increases, no, magnetizing current taken by motor increase. Then when magnetizing current increase, power factor will reduce mainly. Speeds will not affect much, and efficiency will improve, given efficiency will decrease with that. Okay, so power factor will reduce mainly. So the option B correct here. Next, presence of dominant 7th harmonic in winding distribution of 3-phase 6-pole 50 Hz induction motor may cause motor to crawl at a speed about dash. So we know crawling takes place due to harmonics, and under running condition of motor, which harmonic is responsible for crawling is 7th. Under braking operation, 5th harmonic it is. So 7th harmonic is they given. Now at what speed it will crawl? It will crawl at 7th harmonic, corresponding speed is 1/7 of fundamental speed, which is ns. So 1 by 7 into ns, how many poles given? 6 pole, 50 Hz, nothing but what is the synchronous speed for 6 pole? 1000. So 1 by 7 into 1000, we get 143 point something rpm. Okay, so option B is correct. So this is from a single phase induction motor. At the time of starting, the winding of a 230 volt 50 Hz split phase induction motor have the following parameters. So main winding resistance reactance, starting winding resistance reactance. Current in main winding they are asking. So what is the current? Voltage by impedance of that main winding directly, 230 divided by root of starting, r square plus x square directly, 3 square plus 4 square, this is 9 plus 16, 25, root 25 is 5, 230 by 5, 230 divided by 5, calculate how much we get. So it is 46 amps we get, 46 amperes it is. Next question. See the question. A three-phase alternator generates an open circuit phase voltage of 4 kilowatts. Open circuit phase voltage directly given. Actually, if you do open circuit test, the voltmeter will give line voltage there. But directly they mention phase voltage 4 kV. When exciting current is 50 amperes or field current is 50. The short circuit current for same excitation is 800 amps. The synchronous reactance. We have synchronous reactance or synchronous impedance. What is that? Open circuit voltage to the short circuit current for the same value of field current. So, same value of field current they given already. So, directly you can substitute here. Voltage is 4000 divided by 800. Then it is 5 ohms. So, they are asking reactance means resistance negligible. So, Zs equal to Xs only. 5 ohms it is. Option B. Next. When load on alternator is increased, the terminal voltage increases if load power factor is dash. So, we know when load increase, terminal voltage increasing means what is the regulation we get? E minus V. E minus V will be negative. Okay. Or if you can also go to characteristics also. When current load or current increasing, the voltage increases means that is for leading power factor only. For the leading power factor only, the terminal voltages increase. So, there only we get negative regulation or leading. Okay, remember this. Next, when n number of alternators are operating in parallel, then power factor at which each operates is determined by dash. Generally, 2 alternators we discuss, 2 or 3 or 4 or any number of alternators. If n number of alternators working in parallel, if you want to change power factor of any alternator, which one we have to prefer is excitation always, excitation. But if you take single alternator case, single alternator supplying some load, then its power factor depends mainly on the load side. Whatever load we connect, correspondingly the power factor will change. But whenever it is operating with so many alternators in parallel or bus bar, then mainly field excitation we have to change here. So, option C correct for this. Next, a 3-phase 16-pole alternator has the star connected winding with 144 slots and 10 conductors per slot. Considering KD, KP directly given, pitch factor, distribution factor, flux per pole 30 milliwebers and speed is 375 rpm. Then line EMF they are asking, line voltage. So, little calculation required here. Okay. Now, what is EMF induced per phase formula? 4.44 phi F turns per phase Kp Kd, pitch factor and distribution factor. So, here flux everything given directly, but not turns per phase. Turns per phase we have to calculate. See, 144 slots and 10 conductors per slot. Then what is the total conductors? Total 144 slots no, into 10 conductors in each slot. Total is 1440. Then how many turns are there total? Half of the conductors always means 1440 divided by 2. We get it is 720. 720 turns totally. But we need turns per phase in the equation. Then what is the turns per phase? 3 phase now, 720 divided by 3. Nothing but we get how much it is? 3 2s 240. Turns per phase 240. Now substituting here EMF per phase first equals to 4.44, flux is given 30 milliwebers, so 30 into 10 power minus 3, and frequency. So it depends on the speed, you have to check once. 16 pole 375 rpm, then what is the frequency? N into P by 120, N is 375, poles are given 16 divided by 120, then simplify we get 50 Hertz only it is, okay, 50. Now 50 turns per phase 240, Kp is given as 1 pitch factor, Kd given as 0.96 it is, okay. Now if you find, we get EMF induced per phase here is 1534 coming, check 1534.4 something volts, but this is phase voltage, okay. They are asking line voltage, no? As it is star connected, root 3 times, root 3 into 1534 something, then approximately it is coming 265857 or 2658 in the options is there, 2658 option D is correct, okay. Next, the losses in an alternator are more comparable to dash. So here little will confuse because machines is there, transformer also there. So 100% compared to all rotating machines, transformer will have the least losses. So the losses in an alternator are more comparable to dash. Definitely it is comparable to transformer, more or not? Yes. So directly you can take this. Okay. And other rotating machines having there may be squirrel cage or slip ring, this one, induction motor and DC machine. So their losses anyhow more, but compared to which one, definitely it is more? Transformer. So directly you can take transformer here. Next. When alternator operates at a load power factor of unity, power factor is unity, the effect of armature reaction. So what is armature reaction for unity power factor load? Cross magnetizing effect. No? Cross means if main flux is like this, the armature flux will be perpendicular to that. Okay, this is cross effect we call. Then due to cross magnetizing effect, what problem we get? Distortion. So this is wholly distortion only. Okay, means completely distortion because of this cross magnetizing effect, 90 degrees. Next, in three-phase star connected generator, if the fundamental and third harmonic voltages in each phase are V1 and V3. So every phase is having voltages in a star connector, fundamental voltage plus third harmonic voltage, line voltage, V1 and V3 phase voltage. They are asking line voltage of the generator. See, when we calculate line voltages, the third harmonic voltages will cancel in that, VAN minus VBN, like that we write now. Then these third harmonics are zero sequence components, so they will cancel. So we have only fundamental, that is √3 times of phase voltage is V1. So this is only will be there, no third harmonics in line. So √3 V1, option B correct for this. Next, a synchronous motor with negligible armature resistance runs at a load angle 20 degrees at rated frequency. Okay, resistance negligible. If supply frequency is increased by 10%, keeping other parameters constant, the new load angle will be dash. So here frequency increased by 10%, remaining other things means load, excitation, everything constant only. So as load everything is constant, power, active power will be constant here. Power input taken by motor also constant. So what is the power taken by motor? Equation with the resistance negligible, EV by XS sin delta. So power constant here because it is not mentioned about this load or input change or not. So active power is constant. Frequency increased by 10% to this. Okay. So whenever frequency increased in a motor to the motor, the EMF equation related to frequency, EMF proportional to that, 4.44 that. Okay, here EMF also proportional to frequency, this reactance also proportional to frequency. So when frequency increased by some 10%, both E and X, this one increased, this one also increased by same proportion. Then what is this ratio? V constant, only these two changing, and that is also proportionally. So totally this is constant. Then this sin delta also should be constant. Means initially 20 degrees. Now also what should be the load angle? Constant, it won't change. So load angle remains same, 20 degrees only. Okay, next. An induction motor and a synchronous motor are connected to common bus bar, common bus. To operate bus set UPF, the synchronous motor should be dash. So when we connect induction motor, synchronous motor, we know induction motor will draw reactive power from bus bar. Then in order to operate at UPF, as it is drawing, it is supplied by, it should be supplied by synchronous motor. If synchronous motor supplies reactive power to this, that is neutralized. Then total reactive power will be 0. Then it is operating at UPF. For that we know synchronous motor should be operated dash. It should supply reactive power. When it will supply is over excited machine, that may be alternator, that may be synchronous motor, will supply reactive power always. Okay. And over excited synchronous motor always operates at leading power factor, which supplies reactive power and absorbs active power. So it is over excited here, option C. Next, a 1500 kVA star connected 6.6 kV salient pole synchronous motor has XD, XQ given respectively, armature resistance negligible. What maximum load motor can supply without loss of synchronism if excitation is cut off? So without loss of synchronism. So here whenever excitation removed, because the advantage of salient pole machine is it will have additional power, not only electromagnetic power, we also have reluctance power. So even excitation is removed, that electromagnetic power, that EV by X term will be 0, but we have reluctance power, no? That will be remain same. So it will deliver that reluctance power, which is V square by 2 into 1 by x cube minus 1 by x d into sine 2 delta it is. And we know it is asking here how much maximum load it can deliver. Maximum means when it is maximum, so reluctance power or reluctance torque is maximum at delta equal to 45 degrees, means sine 91 maximum we get. Then if you substitute here phase value 6, this is line voltage, then what is the phase voltage? 3810 by root 3 whole square divided by 2, 1 by x cube, how much? 14.5 ohm minus 1 by x d is 23.2. Okay, this is 1. Then if you calculate this, we get the reluctance power is it is coming around 187 point some 26 kilowatt something. This is reluctance power, but it is not total. So it is 3 phase, no? So we have to take total reluctance power is 3 times of this. This is per phase equation it is. So 3 times of this, then it is coming approximately around 561 to something or 563 from options is there approximately. So 563 kilowatts it will deliver maximum. Okay, still even excitation is cut off. That is the advantage of this. Okay, so these are the questions from total machines we have. So hope mostly we can do here, except 1 or 2 questions little calculations required like this. Okay, without calculator we cannot do. So approximately we can do. So little must be needed, no, calculation, this one and previous one of the EMF equation, magnitude of EMF asked here, this question also. Okay, except that mostly out of 27, 24, 25 you can answer easily here. Okay, so these are questions from machines.